Hi everyone, I'm your TA for this course, Empirical Methods 1, and you can call me Gary, and I'm from Taiwan. So today we are going to introduce you about R, which is the software that we are going to use in this course. So before we enter the R session, I'm going to talk about some information on assignments. So basically, except assignment 5, every assignments, including a term paper, are handed in the form of groups of 2 to 3 students today. And so you can start to reach out to the students in your seminar groups and try to form the group by yourself. And since the deadline of assignment 1 is on Friday 9 p.m., so you had better start working on assignment 1 today. And for assignment 1, you should only hand in the script, which I will show the example in the next slide, since the assignment 1 is just to help you to be more familiar with the operation inside R, so it is not too complex. And before you hand in your script, remember to comment your code, which means that you should explain what your code is about. And then when you hand in your script as assignments, just remember to upload on Athena, which Sonia, another TA, already created the platform for hand in. And you should only upload one per group. So you don't need to hand in assignments by individual. So this is the example for the script as your assignments. So you should have group members, and you should mention which seminar group that you are in, and also the date of the assignment, and also the email that you have, the title, and also the name of script, for example, which assignment it is. And also write down the question mark, since there may not be only one question in each assignment. So here are the deadlines for this course. So just as I mentioned, the deadline for assignment 1 is on Friday, 9 p.m. And assignment 2 is 1 week later, November 13, 9 p.m. And November 16th is the first proposal of term paper. So actually it's only about 2 weeks left. So actually you can also start to think about which topic that you would like to write about in your term paper. And then for the term paper, the preliminary version needs to be handed in before December 8th. And the final version is on January 7th. For the term paper, I will explain it more in detail in the later seminars. So now we are going to introduce R. So basically, R is a free software for statistical computing and graphics. There are not only R can do these functions, for example, Stata or MATLAB, but in this course, we use R. And R is installed on computers in the lab in the building of Department of Economics, but it can also use on your computer because you can download it for free. And there are several platforms for R. And in this course, we use RStudio because it is the most straightforward and easiest for the beginners to operate. So these are the basic components when you use R. So these are also the things that you need to know before you use R. So the first one is called objects. So objects are basically the data. So objects stores different values. So objects stores different values, and there are different types of objects. So for example, vectors, matrices, plots, and regression results, etc. And the second is functions. So functions are the tools that we use to deal with the objects. So for example, addition, subtraction, multiplication, and also division. And the third is called files. So in R, there are two types of files. So the first one is called RDA file. So RDA files are the file that store our data files. So you can think it as a data set. And the second one, the other one is called R files. So R files store scripts, and which I will talk more about later. But basically, scripts are something like recipe that you use to handle the data set. And then the fourth one is called packages. So packages are some useful extra materials, for example, functions or data sets that you can download from CRAN, for example. So packages are actually the extra functions or data sets that you can import from external sources. So when you organize your work, you should save your results in the certain folders that you can remember. Otherwise, it will cause some problems when you operate R, since you cannot find your data sets or your past results easily. So just like I mentioned several minutes before, so we use scripts to record the manual that we would like R to execute. So yeah, so basically, which I will talk about this later. So you can actually work interactively in a console so that the R can immediately execute what you would like it to do. But when you working in R, basically we use scripts much more usually, since when you put your code in your console, it will disappear after R executed. But when you put it in scripts, it will not disappear and will be recorded even after the R execute the command. And when you save your script file, just be remember to mention the what it is. For example, if it is for the assignment 1, then you should mention it as assignment 1 and then your name .r. So if you would like to know more about R, so basically on internet there are already quite lots of information about R. So the first one is a brief guide to R for beginners in econometrics, written by our lecturer, Mahmoud. And it is also on Athena. So if you have time, you can check it. And then a very short R reference card. So you can also check it as well. And then the third one is an introduction to statistics using R. So this is useful for those with no background in statistics. But of course, other than these three sources, there are also many textbooks or videos talking about R that you can check as well. So now we are going to enter the R session, really. So now we enter the surface of R. So the first thing that we are going to do is we are going to open a new script. So you click here, File, New File, and then R script. And then you can see that the scripts pop up in the upper left corner here. So here is where you type your code. And let me introduce a bit about the surface of R. So you can see here is the script where you write your code. And then the lower left corner is the console. So where you can also write your code, but it is more interactive, which means that once you enter your code and then the R execute it will disappear immediately. And the console also shows the past history of the result that you executed. And the upper right corner is the environment, so which shows the data set or the objects that you created or imported. And the lower right corner shows files or the graph that you plot or the packages that you imported, or help. So where you can also try to find the answers about the questions that you would like to know. So basically, this is the surface of R. So now we are going to create a folder where you are going to save your files in the computer. So which means that now we are going to set the working directory. So how we set the working directory is that we type setwd, so this command, and then type the folders that you would like to put your data set or scripts in. So to set our working directory, we type setwd, so which means that set working directory, and then type the folders that we would like to operate in. So for example, I would like to set my working directory in user desktop project 1. Oh, I forgot to put the double quotation mark. Yes. So now the working directory are in the project 1 folder in the desktop. So after we set our working directory, then we can start to create objects. So just like I mentioned, objects is the you can think it as a folder which stores the value. So for example, since R can do some calculation, so for example, now I would like to know what's the sum of 1 plus 1, then I can execute it. So execute is to highlight the line that you would like R to execute, and then click run. So you can see that here it says that 1 plus 1 equals 2. However, now I want to store the results of 1 plus 1. Then I need to create an object stores the result. So for example, I would like to create an object called x to store the result of 1 plus 1. Then I write x. So one thing that I need to mention is that, so R is really sensitive to case. So if you write capital X, it is different from the small letter x. So this is the thing that you need to keep in mind. So when you create an object, so you create an object called x and then assign it. So this is an arrow and then 1 plus 1. So when you execute this line, so it means that now I store the result of 1 plus 1 in object x. So you can see here in the environment, now R says that you create an object x, which stores 2, which is also the result of 1 plus 1. And if you want to show x in the console, there are two ways that you can do it. So either you directly type x and then execute it, or you type print. So print is the command that you can print the values of objects. So print x. You can see that the console will also show the result x as well, which is 2. So not only addition, but also R can do the calculation of subtraction, division, and multiplication as well. So for example, I want to calculate a plus 9 divided by 6 minus 7, something like this. And you can see that the result is minus 17. So this is how we create an object and also try to do some simple calculation with the help of R. And now we turn back to our slides. So you can see these slides that we just do the things that, the slides mentioned. And now we are going to talk about more details about objects. So the thing that we just create are actually some number values, so which is called scalar. So scalar is a vector of length 1 because it only contains like one value. However, you can also create vectors using the function C that stands for combine. So for example, this example is that I assign a vector which is called 1, 2, 3, 4 as y. So you can see that, so y is a vector of length 4. And actually, besides numbers, you can also create a vectors of words. And to remember that when you create a vector of words, the characters have to be surrounded by quotes. So you can see from the example. So I want to assign a vector called hello and world as object hello. So I write C and then hello and world. And you can see that the hello and world, two words, are surrounded by the double quotation marks. And this is a vector of length 2 because it only contains two values in the vector. And then y is a vector of length 4 because it contains 4 values. So now we are going to do some exercises to practice the thing that we just mentioned. So the first question in the exercise is create an object called A, which contains 3. And then the second question is create an object B, which contains values 3, 6, and 9 in order. And then the third question is try to create an object C as a third of B. And then the fourth question is try to create an object D as 2/3 of B. And then the fifth question is try to create an object called colors, which contains blue, orange, green, and yellow in order. So now here you can actually put a pause and to think about how to do these questions. And now we are going to talk about the answer. So let's go back to our session. So the first question is try to create an object A called contains 3. So just like we mentioned, so we try to assign 3 as an object A. So this is the answer for the first question. And then the second one is try to create an object B which contains values 3, 6, and 9 in order. So since it contains multiple values in one object, so we need to use vector to record them. So to create a vector, we need the function C. So we type C parenthesis, and then 3, 9, and 3, 6, and 9. So when we execute them, so you can see that from the environment, now we create a value and object A contains 3, and then another object B contains 3, 6, and 9. So this bracket means vectors, so which means that its length is 3, 1 to 3. And then now we create an object called C, which is 1/3 of B. So now we are going to do some simple calculation. So which is B times 1/3. And then for D, it's similar with C. So it's B, which is B times 2/3. And then the fifth question is, now we try to create an object called colors, which contains blue, orange, green, and yellow. So since it also contains multiple values, so we also need to use vector. But now since it is strings, so which is consist of characters, so you need to use double quotation mark to surround them. So which is colors C. So the first one is blue. The second one is orange. The third one is green. And the last one is yellow. So if you feel a bit unsecure about the results, you can print it. So print colors. And you can see that in the console, when you use print commands, you can see blue, orange, green, and yellow here. So let's get back to the slide. So we also have answers in the slide as well. And next, so actually we can also use functions to do some operation of objects. And also we can get access to a particular entry of a vector, since you can see that there are multiple values. So now we get back to the R again. So now I create another vector called Y, which contains 1, 4, 9, and 16. So just as we mentioned on slides, actually we can use some functions to do some calculation of y. So for example, now I would like to know about the square root of y. So I type sqrt, which stands for square root, and then y. And when I execute it, you can see in the console, it will show 1, 2, 3, 4. Or if I would like to know the values of log y, I can also type log y as well. So you can see that it also shows the value of log y here. And if I would like to get access to a certain value in y, so for example, I would like to know the first value of y, then I can type y and then bracket 1. So which means the value of the first position of y vector, which is y. So if you feel a bit insecure, you can try another one. So for example, y3, so which stands. So which stands for the third position of y. So as we know that the third position of y is 9, and we can check it. So y3, you can see that here is 9 as well. Of course, you can also get access to multiple values that you would like to know. So for example, I would like to know the value of the first position to the third position. Then I will type y bracket 1 and then colon 3. So when I type this, then I can get access to the first position to the third position of the value in y. So you can see here has 1, 4, and 9. So now we will get back to the slide. So now we are going to talk about another thing called data frame. So we say that objects is the thing that stores the values. For example, either it is numeric or characters. And data frame is the data set of objects. So objects stores value, and then data frame stores objects. So for example, on the slides there, so for example, you can see the example on the slide. So I create 5 objects, and then I create 5 objects. So 1, 2, 3, 4, and different names, and then different values. And then I type data frame to store these objects. And then here, like student equals A, name equal B, surname equals C, age equal D, and then sex equal E. So basically, this command means that I rename those objects and then store those values inside data frame and then call it names. So now I will show you a like simpler example on R. So let's get back to R. So for example, now I would like to record the grades of students. And so I create an object for the students. So there are student A, student B, student C, and student D. And there are their grades. So for example, 90, 60, 85, and 70. So example is like this. And then I would like to put these values together in the data set, which I name it as grade. So I use data frame to store those values. So data frame. So I rename it. So I call students equals A, and then grades. So I use the capital S, and then grades equal B. So you can see here. So before we only have values, and now we have data sets. So basically you can think data frame as data sets, which stores different objects inside. So if you want to know what grades look like, you can actually print grade. Oh, sorry, since I already named A and B before, so we shouldn't do this. So I would like to name it M and N. So students equals M, and then grades equals N. So if we do it like this, and then we print grade, so you can see that students A got 90, student B got 60, and then student C got 85, and then student D got grades. So this is to print the result of data frame. Of course, you can take a look at grade as well. So we use view. Oh. So we use view. So just remember that you should use V as capital letter. So when you execute view, and you can see that a grade pop up in another window is here. So now let's turn back to the slides and do some exercise. So now we get back to the slides. So try to create a data set which records the capital and GDP of Sweden, Norway, and Finland. The capital of Sweden, Norway, and Finland is Stockholm, Oslo, and Helsinki. And GDP of three countries are 551.135, 434.937, and 275.321 respectively. So now you can put an pause and then try to think about it. But now we are going to give you answer in R. So to answer this question, so we need to create three objects. So the first one is country, and the next one is capital, and the third one is GDP, right? So now we create the objects of country first. So we use P, and then we assign P as three country. So Sweden, Norway, and Finland. And then the next one is capital. So it's Stockholm, Oslo, and Helsinki. And then the third one is GDP. So we assign it as R. So it's 151, 1.5, and 434.937, and 275.1. So now we have three objects, right? And then now we need to put them in the data set. So we call this data set as geographic information, geoinfo, and data frame. So we name the first objects as country equals P. And then the second is capital equal Q. And then the third one is GDP equal R. So now we can check this data frame. So we use view, geo, info. So you can see that now we create a form which records the capital and GDP of three Nordic countries. So Sweden, Norway, Finland, and their capital and also the GDP. So this is the answer of this exercise. So since now we create a data set, so what if we would like to store it as a real data set file, not only the thing inside our system? So now we use save command. So save the data frame called geoinfo. And then the file equal double quotation mark We call it geoinfo.rda. So remember that the RDA file that we just mentioned several minutes ago. So RDA file is the dataset file. So if you execute this code, then you can store your data frame as a real RDA file in your working directory, which is the working directory that we set in the very beginning. So which is called project 1. So now let's take a look at project 1. So now you can see that in the project 1, we have geoinfo. So we successfully create a data set and then store it as RDA file. So this is the exercise that also the introduction of R that I would like to do today. So thank you for your listening. And you can try to form your group yourself. And if you still cannot find any group members, just feel free to email me and I will help you to form groups. Thank you.